Hello everyone. So as part of Satkam activity, I will be showing to you our presentation about the case study provided by the Satkam. So I'm Mituza, and as a part of the case study, I'm from the product engineering team, and today I'll be walking you through how we are planning to transform the app experience and solve some key issues in the new electric scooter version. Our goal is to make it simple. We want to climb from fourth place in the market to at least second, and to do that, we need to get everything right this time. So, um, let me start by talking about the app. The current version, the current version about the app has a bunch of complaints from late notification to an outdated app. So we imagine an ideal scooter app would look like. First and foremost, it should show real-time battery updates with an accurate prediction of how far the rider can go. It should also send timely alerts whether it's low battery, service reminders, or charging updates. Then there's location tracking, super useful when you forget where you parked or just want to keep tabs on your vehicle. I did also love to include trip history so riders can track their usage. And of course, document upload is a game changer. No more carrying your RC or insurance papers around. But if I had to pick the five features that matter the most, I'd say it's the real-time battery prediction, live tracking, reliable alerts, document storage, and integration with Google Maps. These features don't just add value, they solve real pain points. Battery anxiety goes down, navigation becomes smoother, and the entire riding experience feels smarter. Now, speaking about the document storage, it sounds simple on paper, but there's a lot that goes into designing it well. First, it has to be super easy for users to upload documents via the app and then view them right from the dashboard while riding. But security here is non-negotiable. We are talking about the personal documents, so we need to be solid encryption during both upload and storage. Only the verified users should be able to access them, and everything needs to be backed up securely, preferably on a cloud infrastructure that complies with data privacy standards. Now, coming to the customer complaints, there were two that really stood out. One was about charging taking longer over time. That likely points to battery degradation or maybe poor thermal management. To test this, the company can simulate frequent charge discharge cycles and monitor how performance changes over time, especially charge speed and capacity. The second issue was that the app shows outdated info, like old battery stats or ride data. That smells like a backend sync issue or poor refresh logic. So for that, the company can run tests where the network is interrupted mid-season or when multiple users try accessing data at once, just to make sure everything is working fine and stays accurate and is given in real time. In short, this isn't just a new version of the scooter; it's a reboot. Now, my friend will be continuing.
So let's discuss about the root causes and a test scenario. So let's begin with the critical issue affecting user experience. So our primary concern is the battery running out without warning due to faulty prediction algorithm. For solving this problem, we are implementing a testing across a 500 cycle with a validation of threshold 20%, 10%, and 5%. So we have also identified the app displaying outdated information from a snack, delay, or a stealth catches. Our testing will be simulated a vehicle state, changes to major update, and a responsiveness. So additionally, we are conducting a network interprets test to ensure the app remains robust during the outstages, verifying that the red tree mechanism function properly maintained and a data integrity when a connectivity is a comprehensive. So this is all about the root causes and a test scenario of our app. So next will be the effective planning for a app release. So for our releasing app or releasing planning, we are using both inside out and outside in approaches. Internally, we are identifying a core user problems, residing the UI for a better usability, conducting a beta test with employees and a loyal customer, aligning with our new dashboard UX, the preparing a training materials. So extremely we are gathering user feedback, analyzing a competitor features, monitoring app storage review, engaging with the influencer for a pre-launch production. So, and of finalizing a comprehensive launch plan with the support channels ready to assist the user. So, next, priority matrix for app features. So our priority matrix divided features into two levels, P1 for a must haves and P2 for a secondary function. The 5P1 features are a battery health monitoring, navigation integration, and a smart charging alert, remote lock and unlock, and a document vault. So P2 features a tripe history, uh, service reminders, OTA updates, emergency SOS, and a UI customization. So will follow once P1 features are stable. So my friend will be continue.
Hello, I am Mahesh. Today I'll walk you through our strategy to tackle cloud performance issues, add AI-driven intelligence to our scooters, and track critical matrices. Let's start with cloud data performance issues. One of our critical pain points has been slow data syncing between the scooter hardware, cloud, and user app. After through analysis, we identified three root causes: inefficient data models leading to heavy payloads, backend architecture not optimized for real-time updates, latency from a centralized cloud region distant from our users. To address this, we propose three key improvements: transitioning to an event-driven architecture using lightweight protocols like MQTT for faster communication, leveraging edge computing to enable real-time decision making closer to the user, optimizing database operations, and introducing cache layers. These tips will ensure a more responsive app experience and reliable data flow across the system. Now move to the next slide, intelligent recommendation and EML use cases. Our vision is to make the scooter smarter with every ride by collecting granular data such as battery health trends, driving behavior, route preferences, and braking patterns. We will train machine learning models to deliver actionable insights such as personalized battery saving tips, driving habit improvements for safety, a predictive maintenance alert to reduce downtime, eco-friendly route recommendation. Additionally, ML-powered anomaly detection will flag issues like sudden battery drain or erratic driving, enhancing both safety and user satisfaction. Now, let's move to the key business and operational matrices. This outlines how we'll measure success. We have defined two categories of matrices. First one is business matrices and second one is operation matrices. In business matrices, profit per value sold, total units sold with a bold target of 50 plus percentage customer acquisition cost. In operational matrices, average bug count per release, delivery time from order to user, support ticket resolution time, of app crash free rate. Tracking this ensures we stay aligned strategically while maintaining execution excellence. Closing transition. This brings us to end of core challenges and solutions. Now, my friend Yesh will continue.
So let's take a moment to understand how far we have come and where we are going in the electric vehicle journey. The timeline begins with early EVs in the 1800s. In the 1800s, the first electric vehicles were developed, marking the dawn of electric mobility. After a decade in the 1900s, EVs outpaced by fuel engines. In the early 1900s, gasoline-powered vehicles gained popularity, overshadowing electric vehicles. And in the 2010s, thanks to Tesla and better lithium-ion batteries, we saw a massive comeback. Today, we are in the age of connected smart EVs. We have AI-driven apps, real-time analytics, and IoT inside vehicles. Fast forward 10 years, I believe we will see solid-state batteries with a faster charging and longer life, self-driving capabilities integrated with scooter, then vehicle-to-grid V2G tech for smarter energy use, and hyper-personalized ride setting using AI. This space is not just evolving; it's transforming. Then let's move towards the dashboard UI design and interaction. We wanted to create a clean and intuitive dashboard UI for the scooter's tablet. So first of all, real-time monitoring. It will show display speed, battery percentage and navigation map seamlessly. Then swipeable document access, that you can swipe to access uploaded documents and music playlist. Then gloves usability, large buttons designed for easy interaction while wearing gloves. Then default information display, that is default screen will show battery status, alert and range information. Then interactive touch gestures, supports swipe, tap and hold for various interactions. Lastly, what metrics should guide us? From a business lens, the company is likely tracking sales growth, customer retention, then app rating on the Play Store and the App Store, then per unit profitability, then NPS, that is a net promoter score. And in the aspect of the engineering metrics, crash free sessions, then data sync speed, that is a cloud to app, then battery indicator accuracy, time to fix bugs, OTA, that is over the air updates success rate. To sum up, this presentation walks through a complete improvement cycle from understanding user pain points, prioritizing solution, ensuring quality, embracing smart tech like AI, and measuring what matters. Electric vehicles are more than transport, they are the future of sustainable mobility, and it's our job to make that future intelligent, reliable, and delightful. Thank you for listening.